Welcome back. In this video, we are going to solve problem 10-82 that is taken from chapter number 10, Strain Transformation, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. And the topic that we are covering is theories of failure. So statement is the state of stress acting at a critical point on seat frame of an automobile during a during a crash is shown in figure. Determine the smallest yield stress for steel that can be selected for the member based on maximum shear stress theory. So you can see this is the state of element or state of stress on the seat of a crash of automobile. The state of stress is shown over here in this figure, so you have to determine the smallest yield stress for the steel. So let's start with the solution. As we have been given this state of stress, I will draw it a bigger over here. So this is the state of stress here. This is 80 ksi, clear, and the shear stress is how much? 25 ksi. Okay. So if I draw this axis as x-axis and this as y-axis, so you can see this axis is perpendicular to this plane. So this plane is perpendicular to x-axis. So we will take this as sigma x. So here we have sigma x is 80 ksi. Also you can see on y-axis there is no stress. So sigma y is 0 ksi, and we have tau of xy, which is equal to plus 25 ksi. Why it is tau of xy? Because you can see this plane is perpendicular to x-axis and the shear stress acting on it is tau of x in the direction of y. X represent plane or which this shear stress act, and y in positive direction. So that's why this is positive. Now we have all these values. So what we will do is that we will find in plane principal stresses, or you can also say that we will find principal stresses. And how we'll find this principal stresses? So we know that principal stress sigma 1 comma 2 is equal to sigma x plus sigma y divided by 2 plus minus sigma x minus sigma y divided by 2 whole square plus tau of xy whole square. So just put the value. Sigma x is 80 plus 0 divided by 2 plus minus 80 minus 0 divided by 2 whole square plus tau of xy is 25 whole square under the root. Okay, so sigma 1 comma 2 is 80 divided by 2 plus minus under root 80 divided by 2 whole square plus 25 whole square. Now with the help of calculator, we will calculate the term in the square root. So 80 divided by 2 whole square plus 25 whole square under the root will give you the value, which is 47.169. Okay. Now from here we will get sigma 1 is equal to 40 plus 47.169, and sigma 2 will be equal to 40 minus 47.169. So 40, this will be equal to 87.169 unit is ksi. This is sigma 1, and sigma 2 is equal to 40 minus, so it will be minus 7.169 ksi. Now you can see both sigma 1 and sigma 2 have opposite signs. So what we will do, we know that according to maximum, I will write maximum shear stress theory, we have maximum shear stress is sigma 1 minus sigma 2 mod is equal to sigma yield. So this is the condition for failure, for yielding or for failure. For yielding, this is the condition. I will show you here also if you want to draw the more circle for this So I will take two axes. On x-axis you have normal stress, and in y-axis you have shear stress. So sigma 1 is positive. Let's say this is sigma 1, which is equal to 87.169 ksi, and sigma 2 is minus, which is, for example, this is sigma 2. So sigma 2 is minus 7.169. So if you draw the Mohr circle between these 2 points, so I will roughly draw it, so it will be like this. Clear? This will be the Mohr circle. Now here sigma 3 is equal to 0. So if you draw the Mohr circle between 2 and 3, it will be like this, and from 1 and 3, the Mohr circle will be like this one. Okay. Now the maximum shear stress will be this one. This is the maximum shear stress which is required. We have to find. This is the maximum shear stress due to this loading. And this maximum shear stress is equal to this sigma 1 minus sigma 2, sigma 1 minus sigma 2 divided by 2. Clear? So sigma 1 minus sigma 2 will give you how much? Sigma 1 is 87.169 minus 7.169 divided by 2. So I will get 87.169 plus 7.169 divided by 2 will give you 169. This is the value of maximum shear stress due to loading. And we know that maximum shear stress is equal to sigma y divided by 2 for uniaxial tension test. And this maximum shear stress, which is tau max, I will write it here. This is sigma 1 minus sigma 2 divided by 2 should be, for failure, it should be equal to sigma maximum shear stress in uniaxial tension test, which is sigma y divided by 2. I will write it is, this is also maximum shear stress. Okay. So you can, the 2 will cancel. So we will have sigma 1 minus sigma 2 will be equal to sigma yield, which is written over here. Okay. Now sigma 1 is 87.169 minus 7.169 is equal to sigma yield, which is how much? Which we are going to find. Sorry, sigma y is we have to find. Okay, so 87.169 plus 7.169 will give you 94. So sigma y is 94.3 ksi. So this is the yield stress of the material that is obtained from this state of stress that is shown in the figure. And I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.